Okay, so for problem number 1, find the derivative of a. Okay, so remember the derivative of ln of u would be 1 over u times the derivative of u. So the u is x to the fourth plus 8. So it would be 1 over x to the fourth plus 8 times the derivative of u, which would be 4x to the third. So my derivative is 4x to the third over x to the fourth plus 8. Okay. For b, we have x ln of cosine of 3x minus x to the third. So we're going to have to use the product rule. U is x, b is ln of cosine 3x. So the derivative of u would be 1. The derivative of b, it would be, again, the derivative of ln is 1 over u times the derivative of u. So it's going to be 1 over cosine of 3x times the derivative of cosine of 3x. So derivative of cosine is negative sine of 3x times the derivative of the inside. So derivative of 3x is 3. So dv would be negative sine of 3x over cosine of 3x. And then we're going to put the 3 in the front. So the derivative of u times v plus the derivative of v times u. By the way, another way I can rewrite this just to make it easier, sine of 3x minus cosine of 3x would be tangent of 3x. So the derivative of v times u so that would be the derivative of x ln of cosine of 3x. The derivative of x cubed would be minus 3x squared. So there would be my derivative. Find the derivative of e to the pi x minus ln of pi x. Okay, so we're going to have the derivative of e to the u is e to the u times the derivative of u. So remember, pi is a constant. So derivative, if we let u be pi over pi times x, the derivative of u would just be pi. So we're going to have pi e to the pi x minus derivative of ln of e to the pi x. Again, the derivative of ln is 1 over 1 over u times the derivative of u. So we're going to have pi okay, e to the pi will cancel. So we're left with minus pi. Okay. The derivative of log 12x to the third. So remember the derivative of log any base u would be 1 over the ln of a times u times the derivative of u. So in this case, a is 12, u is x to the third, and du would be 3x squared. So my derivative can be 1 over ln of 12 times x cubed times 3x squared. Okay, and for e, Okay, the derivative of a to the u is ln of a times a to the u times the derivative of u. So a is 10, u is sine of x, du is cosine of x. So my derivative would be ln of 10 times 10 to the sine of x times the derivative of sine of x, which is cosine of x. Okay, number 2 says find the derivative of the inverse at 2 if x equals y equals x squared minus 5x cubed. Okay, so the first thing I need to do is I need to find the value of x. Okay, remember since this is the inverse, this is y. So we have 3x minus 5x cubed is equal to 2. Okay, so my function is 3x minus 5x to the third. So if we graph that, okay, I'm trying to find when the y value is going to equal 2. Okay, so the easiest way is to look at my table. Right here. So when y is 2, x is negative 1. So x would be negative 1. So since I have my x value, I'm going to go ahead and find the derivative and substitute x. So we're going to have 3 minus 15 or negative 12. Okay, so that is the derivative when x is negative 1. So the derivative of the inverse at the y value is going to be the reciprocal. So negative 1 over 12. The function defined by f of x, x to the cube minus 3x for a real number has a relative maximum at. So we're just going to find the maximum. So to find the maximum, I have to find the derivative or find the critical points, where the critical points is where the derivative does not exist or the derivative is equal to 0. Okay, so my derivative is 3x squared minus 6x. Okay, so the derivative will exist at all points in the domain. So I'm just going to set this equal to 0. Okay, so x is going to equal 0 and x equals 2. So both of these are critical points. Okay, so I'm going to find to see which one's my relative maximum. We're going to do the line. So I need a number to the right of 0. So let's pick negative 1. So we're going to substitute that into my derivative. So 3 times negative 1 is a negative, and negative 1 times negative 2 is a negative. So a negative times a negative is a positive. So remember, once you check the number, cross it off. So a number between 0 and 2 is 1. So 3 times 1 is a positive. 1 times negative 2 is a negative. So this would be a negative. So number to the right of 2. So 3 times 3 is positive, and 3 minus 2 is positive. Okay, so this is my local max and my local min. So it has, for all real f, has a relative maximum when x is equal to 0. Okay, number 4. Okay, we're going to have to use implicit differentiation to find dy dx. So to find the derivative, that would be 2x. I'm going to have to use the product rule. So u is x, v is y. So the derivative of u is 1. The derivative of v is y prime. So the derivative of u times v plus the derivative of v times u. And the derivative of 3 is 0. So x y prime is equal to negative 2x minus y. And then if we divide, we get negative 2x minus y over x. Okay, so this is my derivative, but I need to find my derivative when x equals negative 3. So in order to do that, I need to find the y value. So I'm going to substitute x into my original equation to find the y value. I'm going to have negative 3 squared plus negative 3 times y equals to 3. So 9 minus 3y equal to 3. Subtract 9, so I get negative 6. So y is 2. Okay, so now I'm going to substitute those into my derivative. We're going to have negative 2 times negative 3 minus 2 all over negative 3. 6 minus 2. Okay, so my derivative when x equals negative 3 is 4 over negative 3. Okay, if the second derivative is given by this, then the graph has a point of inflection when. Okay, so I'm already given the second derivative, so all I have to do is find where the second derivative does not exist, which since I don't have a fraction or square root, I don't have to worry about, and where the derivative is equal to 0. So the derivative is equal to 0 at x equals 0. It's already factored for you. X equals negative 1 and x equals 2. Okay. So I'm going to use my line test. So I'm going to check negative 1, 0, and 2. So to the left of 0, to the left of negative 1, I'm going to check negative 2. So again, I'm substituting that into my second derivative and see whether my second derivative is positive or negative. So no matter what I put here, since it's squared, that's always going to be positive. So I'm going to have negative number, negative 2 plus 1 is negative. So negative times a negative is a positive. Remember, cross it off when you're done using it. From negative 1 to 0, I'm going to check negative 1 half. So we're going to have a negative times a positive times another positive number. So that's a negative. From 0 to 1, I'm going to check 2. I'm going to have a positive times a positive times a positive. And then to the right of 2, I'm going to check 3. So again, they're all going to be positive. So I only have one point of inflection. And that happens when x is negative 1 and x is 0, because that's the only time that the second derivative changes sign.